This is a solving systems review for Algebra 2, looking at different forms of systems of equations and talking about the different techniques we learned for solving them. We learned 3 techniques for solving systems. We learned how to do it by graphing, how to do it by substitution, and how to do it by elimination. This review video is going to focus on the ones that are algebraic, not the visual ones. We're going to focus on substitution and elimination methods for solving systems. The first one you'll see says solve using substitution. The same thing will be asked on the quiz. It will ask you to use different techniques to make sure you're comfortable with each. When you see something with substitution, you need to have a variable that's been isolated. Nice thing about this problem is we've already isolated the x and we know what x equals. So we're going to take what x equals, and a lot of times I circle it or put it in parentheses, and I'm going to put it into the other equation exactly where the x is located. So I like to circle what I'm substituting, and then I like to draw an arrow to where I'm putting that. So what I have when I make that replacement is I have a 4, and then in parentheses, 2y minus 5. You want to take what you put in and keep it together in parentheses. Plus 6y equals 15. Distribute the 4. You get 8y minus 20 plus 6y equals 15. Combine your like terms, so 8y and 6y is 14y minus 20 equals 15. Add 20 to both sides. 14y equals 35. Now we need to divide 35 by 14. Here's when it does help to have a calculator close by. When you take 35 and divide by 14, you get 2.5. And you can write it as 2.5, 2.5, or 5 halves. Any form is acceptable. That is just the y-coordinate. Anytime you're solving a system, you always need an x and a y because your answer represents the point where they intersect. So I'm going to take the y that I just found, and I'm going to put it back into the same piece that I circled, right where the y is, so we can figure out what x is. So x equals 2 times 2.5, because I just figured out what the y was 2.5, minus 5. 2 times 2.5 is 5, minus 5 is 0. So that means my point is the point 0, 2.5. You always want to make sure you do put it in alphabetical order. The x should come first, the y should come second. No matter which order you actually found them in, it always follows the order x, y. So that is the substitution method. The next one up here asks you to use the elimination method. Elimination method is best done whenever the equations are in standard form. So you have your x's and your y's kind of lined up like they're in columns. What your goal is to get either the x's or the y's to cancel, to eliminate. And the way you do that is you want their coefficients to be opposite. So if you have a 5y, you want a negative 5y. Or if you have a 10x, you want a negative 10x. This is one of the toughest examples of elimination because it can't be done in one step. I want to get these to eliminate, and there's a couple options. What I'm going to do is I'm going to try to get all the y's to have 12 as their coefficient. I need one to be a 12 and one to be a negative 12. So I'm going to multiply this whole top line by a 3. That's going to make that y term be 12. And then I'm going to multiply the whole bottom line by 2. That's going to make that line have a negative 12y. So I need those opposite coefficients. This isn't the only way you could do it. You could try to get rid of x's. If you want to get rid of x's, you're going to have to multiply the top line by 8 and the bottom line by 3. So the x's are opposite. You have a lot of options here. You just want to look and see what you notice right away and what you're most comfortable with. When I multiply everything by 3, I'm going to write next to it what I get. I get negative 9x, positive 12y, and negative 45. Make sure you remember to multiply everything, not just the x's and y's, including the constant. And then I'm going to take the next line, multiply everything by 2, so it's going to double each term. I get 16x minus 12y equals 24. What you'll have happen is your y's have eliminated. That's why I call it the elimination method. Some books call it the linear combination method. The rest of the columns you're just going to add down. I have negative 9x and positive 16x is 7x. Negative 45 and positive 24 is negative 21. Divide by 7. I get x to be negative 3. Again, that's the x. I need the y. Now you have a lot of choices for where you want to put this x. I would go back to one of the original functions. It doesn't matter which one. Put that in for x and then solve for y. I'm going to go right to the second line just because I have a lot of room underneath it. And I'm going to put negative 3 where I see the x. So I'm going to write down what I have, including that negative 3. So that's negative 24 minus 6y equals 12. Add 24 to both sides. So I get negative 6y equals 36. And then finally divide by negative 6, giving me y equals negative 6. And get in the habit of writing your answer as an ordered pair, negative 3, comma, negative 6. It is a point because it's the point where these two lines intersect. The last problem we're going to do in this video is the same type of solving, but it's a word problem. So the layout is a little different. You have to look at the word problem and decide how to write equations to represent what we're looking for. We have school planning and outing. We have a 5-hour outing. We are going to be renting bicycles for $8 an hour, skating for $6 an hour. We know how much money we have is $34, and our goal is to figure out the hours we should spend doing each activity. So the first thing I want to do is I want to come up with variables. My variables need to represent each activity. So I'm going to say that X is going to be the bicycles. And if you want, you can use letter B for bicycles if it makes more sense to you. And then the Y is going to be the inline skates. So you could write S for skates if you like. That means I have two unknowns, so I have to write two equations. I always have to have the same number of equations as I do things that are unknown, things that are missing. Well, one equation is the fact that I know I only have a total of 5 hours to work with. So that means the number of hours that I spend bicycling plus the number of hours I spend skating can only add up to 5. That's all I've got. The next line is going to come with the money aspect, the budget. I'm going to spend $8 for every hour that I do a bicycle and $6 for every hour that I do skating, and I have a total of $34 to work with. So there are my two equations. Once you write the equations, it turns out to be exactly like what we just did on the previous slide. You have a system you have to solve. You can either solve it by substitution or elimination. You might look at this and say, well, this is already in standard form, so I'm going to go with elimination. Other students might look and go, you know, this first equation is really easy to isolate a variable. So if that's the case, you could subtract x from both sides and say that y equals 5 minus x, and then do a substitution. It's really completely up to you. I'm going to take you through a substitution just because we just did an elimination and show you how it works that way, but you could go either way. You could do it both ways just to make sure you get the same answer. So I'm going to take what y equals by adjusting the front line, and I'm going to plug it in where you see the y. So I'm going to have 8x plus 6 parentheses 5 minus x equals 34. Distribute the 6, so 8x plus 30 minus 6x equals 34. Combine like terms. I have 8x minus 6x. That gives me 2x. Subtract 30. So 2x equals 4. So x equals 2. Again, my answer, I need two things. I'm not necessarily going to write it as a point. Instead, I'm going to write each as the number of hours I'm going to spend doing different activities. When I take the 2 and put it back here into the piece I circled, I get 5 minus 2, which is 3. That means I want to spend, x was 2, I want to spend 2 hours bicycling. And I want to spend 3 hours skating. So again, word problems are going to be the same solving technique. You just have to come up with the equations. That's a lot of times the most challenging part. Once you have the equations, then you choose the method you want to use and you solve it appropriately.